Okay, everything you need to know in order to do what we're about to do is on this screen. Okay, most of this stuff we already know. We know the reciprocal identities. We know that cosecant is 1 over sine. Secant is 1 over cosine. Cotangent is either 1 over tangent or it's cosine over sine. And then tangent is sine over cosine. So what's going to happen between these two sections is you're simplifying or you're using these kinds of things to replace and substitute in to see if you can simplify the expressions. The Pythagorean identities we have not done yet this year, but hopefully you remember them from last year. They are sine squared plus cosine squared equals 1, tangent squared plus 1 equals secant squared, and 1 plus cotangent squared equals cosecant squared. Those, again, you'll use parts of those to get replaced with another part. So if I saw sine squared plus cosine squared, I could replace it with 1. If you saw something like 1 minus cosine squared, you could replace it with sine squared. Yep.
Are we going to be able to have like a card?
No. Yeah. The only new thing on that is this, which if you learn this, I'll teach you a trick to get to the other two. Everything else on this page we've already done. Even and odd are the ones that are sign changes. So if you see sine of a negative angle, it's the same thing as negative sine of the angle. That sign would actually change, right? Cosine is the one in which the negative goes away. It doesn't change it. Tangent, it would actually change it. So now instead of saying like, here's, cosine is 3/5, what's cosine negative 1? Now you're just going to get to replace the words cosine negative x with cosine of x. So you'll literally replace the words of it. And then the last one is the cofunctions, which we've also already done. Remember, sine goes with cosine, tangent, cotangent, secant, and cosecant. And we did these with the complements, but you'll also see these where you're just replacing the other with it. So if I see sine of pi over 2 minus an angle, I replace it with the cosine of that angle. And then so on and so forth with the rest of them. So I would say you're going to get these all mixed in together. You got to start to pay attention to things like squareds. If there's a sum with a square, whether it's 2 trig functions or trig function and 1, I always come and check those 3. If I see something like pi over 2 minus an angle, I always go to my cofunctions. If I see a negative on an angle, I always go to my even odd functions. And then the reciprocal ones you already know, so hopefully we'll get a little bit easier with those. So a lot of us remember easily the sine squared x plus cosine squared x equals 1. If you know that one and you forget the other two, first of all, a trick is that the c's go together. Sine and cosine are the only ones that they're both on the same side. The other ones are something plus 1 equals something, or 1 plus something equals the other one. And the 2 c's go together. So that usually helps people remember that cosecant goes with cosine. No, sorry, with cotangent. But the other way to figure this out is if you take this original one and you divide everything by cosine, sine squared over cosine squared becomes tangent squared. Cosine over cosine becomes 1, and 1 over cosine becomes secant squared. So if I divided everything by cosine, I get the second one. And if I take the original sine squared plus cosine squared equals 1, and I divide everything by sine, 1 plus cotangent squared equals cosecant squared. So if you're forgetting it or if you're unsure, that's a quick way to remember the other two. But those are your Pythagorean identities. So you'll see them used in a couple different ways. This is the first way. It says use the given values to find the values of the 6 trig functions. So I'm given sine of pi over 2 minus x equals 12 over 13. And then sine, there should be an x here. Sine of x equals negative 5 over 13. My goal is to find sine of x, cosine of x, tangent of x, cosecant of x, secant of x, and cotangent of x. So the sign's already given. It's negative 5 over 13. What does this mean? Sine of pi over 2 minus x is the same thing as what? Cosine of x. So this is telling you cosine of x equals 12 over 13. So I have choices here. I can build my triangle, set it up, and find the missing side. Or I can use the reciprocal identities and the sine and cosine identity for tangent to find the rest. So this one I get negative 13 over 5. This one I get 13 over 12. And instead of using a triangle, we're going to just practice this. Tangent is sine over cosine. So it'd be negative 5/13 over 12/13. Keep, change, flip. And I get negative 5/13. No, sorry, negative 5/12. And cotangent would be negative 12/5. So it's just another way to do it. You could also have figured out your triangle, but you have to pay attention to the positive, negative signs. Like if your cosine is positive, but your sine is negative, that means you're going to have the negative on the opposite side. All right, example 2 says simplify the given expression. So now there's no values here. I'm not setting up a triangle. There's no numbers involved. This means I'm literally simplifying based on the actual trig expressions that are there. So what would I normally do if I had parentheses and then something on the outside? Distribute. So I'd get cosine of x times secant of x minus cosine of x times cosine of x. Cosine stays cosine, but what is secant of x? 1 over cosine. And cosine x times cosine x, it's weird, but the squared goes on the trig function, not on the variable. So when I multiply them together, it's cosine squared of x. What happens with cosine times 1 over cosine? These cancel, and I get 1 minus cosine squared of x. Is that as simple as I can get it? Where do you see ones in cosine squareds? Sine squared of x plus cosine squared of x equals 1, right? So if I do 1 minus cosine, it means the cosine came over here to the other side. So I can replace 1 minus cosine squared with what? Good. You remember these now, right? Yay. All right, this one says factor, right? Factor the trig expression. So it's actually telling you what you should be doing at the beginning. So when I want to factor, this is a trinomial, okay? We can use substitution with our like a value to substitute in the a, kind of like what we did when we did the e to the x. What we did there, I could say that a equals sine of x, and I can substitute that in. And then I can factor this. I just have to plug the sign back in. So I can multiply first times last here, and I get negative 6. Find the factors of negative 6 that sum to negative 5, 6, negative 6, and positive 1. Substitute them back in place of the negative 5a, and then factor by grouping. Take out a 3a, and the second one is already matching. So I'd get a minus 2 and 3a plus 1. We made a from sine of x, so I have to take that sine of x and plug it back in. So there's the factored form. And for right now, that's all we're doing. 5(3) is, you would then solve that. So you'd set that equal to 0, and you'd actually solve that. But for right now, we're stopping there.
So on the test, there would be ones that we don't.
It'll say solve. Yep. All right, this one says perform the multiplication and use the fundamental identities to simplify. So again, it's kind of hinting to you what to do. I do not distribute, for the love of God. People are still doing this. Do not distribute a squared, right? You have to expand and FOIL this. Yes. So I get sine x times sine x, or sine squared x. Sine times cosine. Cosine times sine. Order doesn't matter there, so I can switch it so they're the same. And then cosine times cosine. Cosine squared x.
So the first and the second one are the same.
Yeah, I just reversed the order. Like it would have been cosine times sine, but that's because multiplication doesn't matter. I want them to be the same term. So even if you wrote it as cosine of x, sine of x, you just got to identify those are the same things because I can combine those terms.
What if I wrote it like cosine x sine x?
It doesn't matter.
Plus cosine x sine x.
It doesn't matter.
Oh, okay.
Yeah. So now these two together give me 2 sine x cosine x. Is this as simple as I can get it? What do you see there that you can replace? Sine squared plus cosine squared is what?
1.
1. So 1 plus 2 sine x cosine x.
So you don't even have to be like right next to each
No? Anywhere in the, because I can rearrange that in any order, right? It's all addition. And that order can be switched to, it can say 2 sine x cosine x plus 1. The order there, again, doesn't matter. Still good? Yes? All right, now it just says your generic set of instructions, which is what you're going to see most of the time. Use the fundamental identities to simplify the expression. So it's not going to hint to factor or hint to multiply or hint. You just have to approach it however you think you can approach it. Now, here's the thing I will say is you never know when they're going to be easy. You have to try them all. So, like, there's no question marks on homework. Tonight's a PDF. There's no question marks. There's always something you can try with these. And it might be the very last one that clicks for you, okay? So if I look at the first one, I've got cotangent and secant. They're both reciprocal functions, right? What can I rewrite there?
1 over tan of theta.
I can make it 1 over tan. And what's secant?
1 over
1 over
cosine.
cosine. So is there anything I can simplify there?
No.
No. What else could I do then instead? Cotangent can be cosine over sine. And then I can cancel out the cosines. I get 1 over sine, which is cosecant. So ideally you get it down to one trig function. That's the simplest form. You know you're definitely done. Okay? It doesn't mean it always happens. Hardest part I think about this is not knowing when you're done. That's why 5-2 is easier, I think, because 5-2 has the equals and you know you're done. All right, look at B. What can I do?
1 minus sine squared equals cosine.
Good. 1 minus sine squared equals cosine because sine squared plus cosine squared equals 1, right? So if I move sine over here, cosine squared equals 1 minus sine squared. So cosine squared can go on the top.
And I think tangent, right?
So what's the expression is tan squared plus 1 equals secant squared. So what's the other one? 1 plus cotangent. The C's go together, if it helps you remember it. The C's go together. Cotangent and cosecant go together. So cosecant minus 1
Cotangent squared.
is cotangent squared. Now I'm going to show you 2 ways to go from here. What's one thing we could do?
1 over tan.
Okay, but think I want to get it in terms of cosines, right? So like if there's a sine or cosine there with a tan or a cotangent, I'm going to make that in cosine over sine instead of 1 over tangent. 1 over tangent is not wrong, but you're going to have to make that tangent cosine over or sine over cosine at some point anyways. So I can do cosine squared x over cosine squared over sine squared. They'd both be squared if the original function's squared. Then keep, change, flip.
Wait, so tan would be sine over cosine?
Sine, yep.
Okay.
And then I can cancel out the cosines and I just get sine squared x. So I keep, change, flipped. And in doing so, I could cancel out the cosines and I was left with just the sine squared. Now, a good trick from here, okay, is that you can actually move trig functions from the top to the bottom or the bottom to the top of a fraction if they are either by themselves or being multiplied by something. Like if it said plus 1 in the bottom, I can't move just cotangent. But if cotangent's there by itself, I can actually move it by making its reciprocal function. So when I move it, it becomes tangent squared. So then I'd end up with cosine squared x times tangent squared. Why did I put it over 1? Times tangent squared. And then that would be cosine squared x times sine over cosine. And the cosines cancel. So you can move any function from the bottom to the top or the top to the bottom by making it its reciprocal function if it's either by itself or multiplied by something. Like if it was 1 over sine x cosine x, I can move sine to the top by making it cosecant, and I can move cosine to the top by making it secant. Does that make sense? Only if it's multiplication or they're by themselves. You can't do it if it said 1 over sine x plus cosine x. I can't move parts of those or even the whole thing. You can't move it like that, okay?
What if it said plus 1? Still no, right?
Still no. If it's part of a sum or difference, you can't do it. So like this one, I couldn't move the cosine. All right, so rewrite the expression so it's not in fractional form. It's basically even telling you can't, like your answer shouldn't be a fraction. So give me something to start with.
Bottom is sine squared.
Why not? It's not squared. The Pythagorean identities have to be squared. You can make this 1 minus cosine squared y over 1 minus cosine. Say it before.
Like cancel.
You can't cancel like this. Is that what you mean?
No, cancel the bottom and then you have only 1 minus cosine.
You can't cancel part, though. How do you cancel the whole thing?
Yeah, like 'cause you have 2 on top and 1 on
But that's 1 minus cosine y times cosine y, right? I can't cancel, like, part. You can't do that. No, you can't. You can't cancel that way. There's a way to cancel, but not like that. You can only take it out if it's on both terms.
Well, why can't you cancel?
Because that's like saying 1 minus, can you do 1 minus x squared over 1 minus x? Can I just cancel that? No, no. You can't cancel part of a sum or difference.
No, yeah, me too.
Maybe if you put your half a brain together with somebody else's half a brain together, we might be able to get somewhere.
Full brain.
What would you do if it was this? You can't move it. You can't move just the you can't move the expression at the top, right?
1 plus x, right? Multiply to the top, like the bottom to the top.
And the bottom, you can only multiply top and bottom. You could do that.
Like
It's on gate.
the denominator to the numerator by multiplying, right?
that?
Like the reciprocal.
Like, are you thinking of like when you're doing like the conjugate stuff, like the square roots?
Like I guess like that's minus x squared over x to get it out.
So if you wanted to get rid of the bottom, you could multiply by the opposite.
Yeah, exactly.
But you're still which here, let's do this. You could do this.
I'll be still fine.
You still have in the bottom, right? You're still going to have it. It's just the opposite sign. So this would be 1 minus cosine squared y times 1 minus cosine y over this multiplied out is the difference of two squares. 1 minus cosine squared y. Then you could cancel this and you could get 1 plus cosine y. That is one way to do it. What's a different way to do it? I heard somebody say it over here.
Split the fraction.
No, you can't split if it's a sum or difference in the bottom. You can split if it's one term. Can you factor 1 minus cosine squared? What is that called? Difference of two squares. So this is 1 plus cosine y and 1 minus cosine y over 1 minus cosine y. Then these cancel and I get 1 plus cosine y. So look for factoring. Like, I know you don't enjoy it typically, but look for things like that. Any difference of two squares can be factored.
Honestly, it's not even that I don't enjoy it. I just cannot do it.
Questions on that one? All right, so now we're flipping gears and we go to 5-2. The difference with 5-2 is you get an equal sign, so you get to know when you're done. That's what makes 5-2 a little bit easier, okay? 5-2, there's a stopping point. This is the exact same reference sheet, so everything you need to know you already know. These are some pointers on how to work around the solving. This is like teaching proofs because they're never the same thing. So I can't say step 1 is this and step 2 is this and step 3 is this, right? This takes logic. So don't get frustrated if you don't get it right the first time. Go to the next one because again, the next one might be the one that's easy for you to do, okay? And you have to at least try them all. There are some tips though. So like the very first thing says rewrite the more complicated side and sign in terms of sine and cosine. So if I have a side of my equation that only has one trig function, I'm usually not going to mess with that one. I'm going to try the other side. And if they're reciprocal functions, I'm going to usually try to get them in terms of sine and cosine because those are the ones that I know I can usually cancel out. The second thing says factor out the greatest common factor. So if I have the same trig function on two expressions, I'm going to try to take it out because sometimes I might be able to simplify that way. The third thing says separate a single term quotient into two terms. So if you have a fraction that has two terms in the top and one on the bottom, you can actually break it apart as long as you keep the same denominator with both. And then you might be able to simplify part of those. The reverse of this is the second or the next part, which is you might have to combine using a least common denominator. So if I have two fractions, I need to get them into one. I'm obviously looking for a least common denominator. And then the last thing says multiply the numerator and the denominator by a binomial factor that appears on the other side of the identity. Sometimes you have to work both sides of your equation. If there's a denominator on the right side, you can multiply it on both sides to get rid of it. So sometimes you can get rid of a denominator by multiplying both sides by it. And then obviously this is a big one. Don't be afraid to stop and start over again. It happens all the time. If you get to a dead end and you're stuck, start it over again. Try something different. All right. Here's the first one.
I don't think any of that went into my brain.
Okay. On the left, obviously I'm going left-hand side, right? It's obviously more complicated than the right-hand side. So what did you say, Sophia?
Wouldn't that equal 1?
Oh, my word. What's cosine squared plus sine squared?
1 equals 1 over, couldn't you do 1 over cosine?
For 1 over...
The other side.
Oh, sure. You're overcomplicating it. I'm telling you, right, you probably will get there. But this, if you left it, is cotangent squared x plus 1, and that is cosecant squared x. So that's one way to do it. But let's say you went with this because, like, you could keep going with this. If I wanted to get that to one fraction, I would have to make this sine squared x over sine squared x. So it has, right, a like denominator. Then it would be cosine squared x plus sine squared x over sine squared x. This is 1. So this would be 1 over sine squared x, which is cosecant squared x. So completely different route. One obviously a little bit less steps than the other, but they are both right. They would both earn you full credit. So just because it's not the way that everybody else does it doesn't mean it's not right. Just has to, at the end, the left side has to equal the right side. And you can't skip steps in between. Like, I know you know where it's supposed to go. You can't just write that answer and get the full credit.
What if I flipped the other side and said 1 over sine x, and then at the end I put it equal to
Like this?
sine x? Yeah.
That's fine. As long as left side equals right side.
So really the word this was.
Yeah. These are easier to do, harder to grade. Yeah. All right, tangent squared x minus sine squared x equals tan squared x times sine squared x. Yup. Yeah. Sure. Give me a first step. I've seen it done two different ways. They were both like probably equally complicated. This one's not like a quick one stepper. The one on the left? The one on the right. This one, turn it into sine over cosine. You can. How would you get that into one?
Put it over the denominator, like make it the same denominator.
Okay, so I'd have to multiply by cosine squared and cosine squared. Then what? Take out a sine squared.
Now there's a 1 minus cosine.
What's 1 minus cosine?
Sine squared x.
Good. So if you can break this up, because it's multiplication, you can actually just break it up. I could take out one of those signs and write it next to it. And that's hard for people to see, but if it's all multiplication like that, I can't do it if it was addition, but if it's all multiplication like that, you can separate that out. And then sine squared over cosine squared is tangent squared times sine squared equals, and that's the other side. Now let's say you got here and you had no idea what to do. You can work this side. I can say, okay, tangent is sine squared x over cosine squared x times sine squared x. And then you could have set them equal to each other. So if you get to a point where you can't go any further on one side because you don't know where to go, you can work the other side. There's no rule that says you can only work one side. Sometimes you have to work both sides. We moved the sign to the other side, took out a sign. So it was tan squared x equals tan squared x sine squared x minus sine squared x. Took out a sign and got tan minus 1. I'm trying to think what else we did. And then that's secant. And then change that to secant. Good luck. Have a happy Thanksgiving. Make sure you watch the end of the video, okay? Because there's an explanation on something to do over the break.
Okay.
That's how they did it. All right, this one says sine of x over cosecant of x plus cosine of x over secant of x equals sine x cosecant of x. So first of all, this is one of those where you have a denominator all by itself, right? If I move those trig functions to the top, cosecant becomes what? Sine. Secant becomes cosine. And I end up with sine squared x plus cosine squared x. What's that? 1. So I'm at a dead end on that side. This is a perfect scenario in which you have to work both sides. Sine times cosecant could become sine of x times 1 over sine, right? And I get 1 equals 1. You could have given a like denominator. You would have had to multiply the left side by secant, the right side by cosecant, and eventually get there. But this is much easier in the movement of the denominators. This is when it's way easier that way. All right. Ideas. Yep, go.
Okay. Convert 1 plus tangent squared to secant squared.
Okay.
Then simplify both the cotangent and the secant squared to cosine over sine times 1 over cosine squared. Then all that over tangent.
Then cancel, right?
Then cancel, yeah. So then you get 1 over sine times cosine over tangent.
Yep.
Then convert the tangent to sine over cosine.
Yep.
Wait, no, you're supposed to keep on cosine because it's cosine squared. You didn't, all the cosines didn't cancel.
Oh, thank you. From here. Okay. Now keep change flip.
Change flip 1 over sine squared.
Cancel, right? You canceled?
Yeah,
Yeah.
cancel.
Then 1 over sine squared.
Then you get 1 over sine squared. 1 over sine squared equals cosecant squared. Cosecant squared equals cosecant squared.
But you still have the code, this x.
Because it's cosine squared.
Because from here, you can only cancel one of them. Yep. Anybody else want to try? No. No. All right, let me show you one more way. This, I would still do the secant squared, but the tangent I would bring to the top is cotangent. So I'd get cotangent squared x times secant squared x. Cotangent is cosine squared over sine squared. Secant is 1 over cosine squared. The 1 over cosines cancel, and I get 1 over sine squared, which is cosecant squared. When you bring the tangent to the top, it becomes cotangent squared. What? Yeah. Because there was already one there.
Oh.
Yeah. All right, one more, and then we're done. Go, Adam.
Would you convert sin x
Can I like do anything with the left-hand side? It's already sines and cosines, right? Which means go to the right-hand side.
Convert. Yeah.
You can't cancel like that. You can't cancel part because it's a sum.
Can you like break them up so like?
You can break them up if they're reversed. If there's one term in the top and two terms in the other way around. One term in the bottom and two terms in the top, you can break it up. But when there's two terms in the bottom, you can't. Yeah.
Convert the tangent to sine over cosine.
So I can make this sine of x over cosine of x over 1 plus sine of x cosine of x. Then in the bottom, like denominators, would be cosine, right? So I make this cosine of x cosine of x. Sine of x over cosine of x over cosine of x plus sine of x over cosine of x. So I took all those tangents and I rewrote them as sine over cosine. That's the top one. This was the one on the right. I changed 1 to cosine over cosine. And then I just combined the denominators. So this is the tangent from the top. And this is what was from 1 plus tangent. All right, when I get to the end, I'll go back up.
Then you can flip that.
Change flip. These cancel, and I get sine of x over cosine x plus sine of x. I've also seen this one done with cross multiplying. It's complicated, but it works. You can cross multiply on these too. But I would say, like, if you've got, it looks like the one on the left is sine and cosine. Those should be easy to but you can't combine those. There's no like denominator there, which means you have to work the tangent side. This is like, it's just like, it's a kindness challenge that you'll be rewarded. I'd love to just like give you a challenge and then have you be good people, but let's be honest, you're teenagers, you need bribery. So I will do that, okay? So I used to do this every year and then I got in trouble and so we have to tie in the math to it. So there's a math, I used to just do this. And that was super fun and easy to read and grade. You can do all of these 8 challenges. That'd be fantastic. You'd be closer to heaven, okay? But I'm gonna give you credit for up to 3. So tell your parents how much you love and appreciate them. It's sad that you don't do that often. 2, call a grandparent, friend, relative if you haven't talked to in a while. 3, make a list of short-term goals and long-term goals for yourself. 4, do something nice for a stranger. And I do not mean hold the door open for somebody on the way out of the classroom. Because I freaking got that one year and that is not worth a bonus point. Like, go out of your way to be nice. Yes. 5, do something you don't normally do. 5, send an email to your favorite teacher, past or present, telling them how much you appreciate them. You don't earn anything extra if it comes to me, because I've also had that attempt. 6, do... That's fine. I'm just not going to give you extra points. 6, do volunteer work. 7, say a sincere prayer of thanks to God for all your blessings. And 8, write a letter of gratitude to someone that's impacted your life. That's like in the video, okay? So if you do these, you're going to fill this out. It says use the space below, and it says reflection. There's a typo, but it should be to reflect on each of the challenges you completed. Use 2 to 3 sentences to share each experience and include the number or description in the challenge that was done. So you can either say, like, I did number 2 and blah, 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 or you can say, I called my grandparent and this is what happened, okay? This is the math portion of it, okay? So we're going to do, I had to. This is in order to give you some kind of bonus, it had to be math related. So,
This is not optional? It's like
this, if you want those bonus points, you have to do this. Yes.
But this three times is optional.
The whole thing is optional, but if you want the bonus, you have to do all of this. So this is basically, I just was like, how do I make this math? So we're doing the exponential effect of paying it forward. So if you are, the first thing is doing a diagram to show the effects of 5 rounds. So you are the first round. If you, as a person, do 3 challenges, 1, 2, 3, then you reach, I'm just going to put a little happy face because I'm tired of drawing. Then you reach 3 people, okay? That's round 1. If those 3 people paid it forward, I would love to see something cute, but yes, that would be round 2. You're going to go all the way out to round 5, okay? And it's got exponential growth. Oh, give me a break. So based on that, you would fill in the chart. The left side is the round. The right side is the number of people affected. So in round 1, how many people were affected? 3. If I did another round, round 2, how many little dots do I get? 9. And then you're going to keep going like that all the way up to round 5. From there, you can make an exponential equation, which is 3 to the x, folks. Okay, each time it happens, it's 3 to the x. And then you're going to graph 3 to the x, which is an exponential function.
Equals 3 to the x.
And then you're going to find the 10th round, so you're going to make x 10.
So you just basically tell us how to do it?
Yes.
Thank you.
You're welcome, okay? In order to get those points. So it'll be up to 3, no, I think it's 5. Up to 5 test points. So if you do 3 challenges, I give you 5. If you do 2 challenges, I give you 3. If you do 1, it's very sad, but has happened, 1 challenge, I will give you 1 bonus point on a test, okay?
So we get 5. If I do all 8.
I can't give you more than 5. I'm giving you 5 max.
5 points?
5 points. That would be the same thing because your tests are out of 100.
Wait. So if I get a 95,
So you're just going to get an extra column in the grade book that says out of 0, and I'm going to put 5 in it, and that means you got 5, and you could go to whatever test. It goes to your overall score. It doesn't matter. Yeah.